Could bacteria from Earth survive the ultimate journey, leaving our planet, traveling through space, and landing on an asteroid? Scientists studying Ryugu think it's possible, and their findings could rewrite what we know about life's resilience and our planet's connection to the stars. Let's unravel this incredible tale. Back in December 2014, Japan's Hayabusa 2 mission set its sights on Ryugu. The mission wasn't just a technological marvel, it was a scientific gamble. Ryugu, or Dragon Palace in Japanese, is a near-Earth asteroid classified as a carbonaceous chondrite. Translation? It's incredibly old, likely as old as our solar system and potentially teeming with organic compounds, the building blocks of life. For scientists seeking to understand how life began on Earth, Ryugu was a treasure chest waiting to be unlocked. But getting there wasn't easy. Ryugu orbits between Earth and Mars, over 300 million kilometers away. Hayabusa 2 traveled for over 3 years before finally arriving. The spacecraft performed something extraordinary. It descended to the asteroid's surface, fired a tantalum bullet to stir up material, and captured pristine samples. Imagine the precision needed to hit a target in space the size of a small town, retrieve fragments of rock, and safely store them. Yet, it wasn't just the journey that was remarkable. It was what the team found when they analyzed the samples. As scientists carefully examined the material, they detected organic molecules, raising exciting questions about Ryugu's role in the origins of life. But then, something unexpected surfaced. Could there be traces of Earth's bacteria on Ryugu? What if something from Earth has been lurking on this asteroid for millions of years? Sounds impossible, doesn't it? But as we'll see, the answer might not be so simple. Imagine bacteria as tiny astronauts, braving the harshest conditions the cosmos can throw at them. These microscopic organisms, some no larger than a single speck of dust, possess an almost superhuman, no, supermicrobial ability to survive. Extreme heat, freezing cold, intense radiation, even the vacuum of space itself. None of these seem to faze the hardiest members of Earth's microbial community. But how do they do it? And could they have hitched a ride into space, perhaps unknowingly? On one of humanity's missions, the key lies in a group of microorganisms known as Extremophiles. These extraordinary life forms thrive in conditions that would be deadly for most other living beings. From the scalding geysers of Yellowstone to the crushing pressures of the deep ocean, Extremophiles are nature's ultimate survivors. In space, they face challenges like cosmic radiation and the absence of water. Yet, studies have shown that certain bacteria, like Deinococcus radiodurans, can endure these conditions by repairing their DNA at astonishing speeds and entering a kind of suspended animation until conditions improve. This resilience makes them perfect candidates for interplanetary hitchhiking. Think about it. Space missions are meticulously sterilized, yet it's nearly impossible to eliminate every single microbe. Tiny bacteria could cling to spacecraft surfaces, tucked away in nooks and crannies, surviving the launch, the vacuum of space, and even re-entry into another planet's atmosphere. It's a phenomenon scientists call forward contamination, and it raises a thrilling yet unsettling question. Has Earth been unintentionally seeding the cosmos with life? What's even more fascinating is that experiments on the International Space Station have proven some bacteria can not only survive in space, but even thrive. Protected by biofilms or embedded in dust particles, these microbes could theoretically endure for years, drifting between worlds. Could these invisible travelers be the pioneers of life beyond Earth? If they've reached places like the asteroid Ryugu, they might offer a tantalizing hint at how life spreads across the universe. So, the next time you think of space explorers, Don't just imagine astronauts in bulky suits. Picture tiny, tenacious microbes riding alongside them, silently defying the impossible. Could these microorganisms be the key to answering one of humanity's oldest questions? Are we alone? Or, perhaps more intriguingly, have we unknowingly sent life ahead of us? How could Earth's bacteria, tiny and fragile as they seem, possibly end up on a distant asteroid like Ryugu? At first, it might sound like the plot of a science fiction novel, but when you dig into the science, the idea becomes surprisingly plausible, and it opens the door to some astounding possibilities. Let's start with the concept of panspermia. The idea that life can travel between planets, or even across star systems, hitching a ride on meteoroids, comets, or other celestial debris. When a massive asteroid collides with Earth, the force of the impact can eject fragments of rock into space. These fragments, some as small as pebbles, others as large as houses, can carry Earth material and potentially microorganisms far beyond our atmosphere. Over time, these pieces of Earth might drift through space and even collide with other bodies, like the Moon, Mars, or asteroids such as Ryugu. In fact, we already know Earth rocks have been found on the Moon and Mars, proving that planetary material exchange isn't just possible, it's happened. But there's another intriguing possibility: human space missions. Despite rigorous sterilization protocols, it's nearly impossible to eliminate all microorganisms from spacecraft. Microbes have a knack for hiding in the tiniest crevices, evading even the most advanced cleaning techniques. When spacecraft like Hayabusa 2 visit places like Ryugu, they could inadvertently carry Earth bacteria along for the ride. Could we have unintentionally seeded Ryugu with our own life forms? Imagine this. Billions of years from now, a future civilization might discover traces of Earth bacteria on Ryugu and wonder if these microbes represent a native life form. What would they conclude about the history of life in the cosmos? This isn't just speculation. Scientists have already documented how bacteria survive extreme conditions during space travel, including radiation and vacuum exposure. Some microbes have even been revived after years in stasis aboard spacecraft. Is Ryugu proof that Earth's life forms are already spreading across the cosmos? Or could it hint at a much older exchange, one driven by the chaos of asteroid impacts billions of years ago? If Earth material, and possibly life, can journey through space, it raises a profound question. Are we the only planet spreading life? Or could we be part of a much larger galactic network of life's cosmic hitchhikers? The answer may change how we see our place in the universe. Think of Ryugu as a cosmic time capsule, one that has preserved secrets from the earliest days of our solar system. When Japan's Hayabusa 2 mission returned its samples to Earth in 2020, scientists eagerly opened this vault, hoping to uncover clues about the origins of life. What they found was nothing short of groundbreaking, but it also left them with some perplexing questions. Ryugu's samples were rich in organic compounds, the very building blocks of life. Scientists detected amino acids, molecules critical to forming proteins and other essential biological structures. These compounds likely formed billions of years ago, providing a direct link to the processes that shaped our solar system. But here's where things get interesting. Some of the material seemed unexpectedly similar to substances found on Earth, sparking curiosity and concern. Could these similarities mean Earth-origin microbes had somehow made their way to Ryugu? This wasn't an easy question to answer. The Hayabusa 2 team had taken extraordinary precautions to ensure the samples weren't contaminated during their collection or journey back to Earth. The spacecraft's design minimized contact with external materials, and the retrieval process was meticulously controlled. Still, the possibility of forward contamination, Earth microbes hitching a ride on the mission itself, couldn't be entirely ruled out. To dig deeper, scientists examined the samples under extreme scrutiny. They looked for isotopic signatures and molecular patterns that could differentiate between material native to Ryugu and anything originating from Earth. The presence of certain isotopes hinted that the organic compounds were likely extraterrestrial, born in the cold depths of space. But even with this evidence, the question lingered. Could any of these microbes or molecules be stowaways, introduced by humanity's own exploration efforts? And then came the bigger question. What does this mean for the search for life elsewhere? If we find lifelike compounds on asteroids, are they evidence of life's cosmic origins, or signs of our own inadvertent cosmic contamination? The answers could redefine our understanding of how life travels through the universe. These discoveries have left scientists buzzing with excitement and puzzlement. Ryugu's samples are unlocking incredible secrets about the building blocks of life. But they're also raising unexpected questions. Could Ryugu hold the key to understanding life's beginnings? Or will it reveal a far more complex story about our place in the cosmos? Stay tuned, because this time capsule might have more surprises in store. What if, in our search for life in the universe, we're not just finding it, but accidentally creating it? The possibility that Earth's bacteria might survive on asteroids like Ryugu, or even adapt to other worlds, raises profound questions about life's resilience and humanity's responsibility in space exploration. Bacteria are remarkably adaptable. Given the right conditions, or even just enough time, they could evolve to thrive in alien environments. Studies show that some extremophiles, microorganisms that already survive in Earth's most hostile places, can endure the vacuum of space, intense radiation, and freezing temperatures. If these tiny survivors landed on an asteroid or a planet with even the slightest resources, could they adapt, multiply, and perhaps even jumpstart ecosystems in entirely new worlds? This idea presents a fascinating but troubling ethical dilemma. On the one hand, the thought of seeding life across the cosmos is thrilling. Imagine Earth's bacteria laying the groundwork for future ecosystems, potentially enabling life on barren planets. On the other hand, this could mean we're inadvertently contaminating pristine environments, robbing scientists of the chance to study extraterrestrial ecosystems in their natural state. NASA and other space agencies are keenly aware of this risk. They have strict planetary protection protocols designed to minimize forward contamination. Yet, as resilient as microbes are, can we ever truly guarantee a clean mission? The implications don't stop there. If Earth's bacteria can survive and adapt on other celestial bodies, it complicates the search for alien life. For instance, if we detect microbial life on Mars or Europa, how can we be sure it's truly alien and not just Earth microbes making themselves at home? It's a question that could muddy one of the most profound discoveries in human history. And what about the long-term consequences? Could these bacteria evolve into entirely new forms of life, distinct from anything on Earth? Could humanity become an accidental creator of life throughout the cosmos? These questions force us to reconsider our role as explorers of space, not just as seekers of knowledge, but as stewards of life. The idea that Earth's tiniest inhabitants might one day colonize the stars is both humbling and awe-inspiring. It blurs the line between discovery and creation, forcing us to confront the ethical and scientific responsibilities of our growing presence in the universe. As we venture further into space, we must ask ourselves, are we simply exploring, or are we sowing the seeds of a new cosmic legacy? Ryugu isn't just an asteroid, it's a storyteller, carrying tales from the very dawn of our solar system. In its dusty fragments lie clues to some of humanity's most profound questions. Where did we come from? How did life begin? By studying Ryugu, we aren't just learning about a faraway rock. We're uncovering the interconnected story of Earth, the cosmos, and the origins of life itself. The organic materials found on Ryugu are a time capsule of prebiotic chemistry, the chemistry that existed before life began. These molecules, formed billions of years ago in the cold depths of space, are strikingly similar to those that would later spark the emergence of life on Earth. Amino acids, for example, are the building blocks of proteins, and their discovery on Ryugu suggests that the seeds of life may not have been unique to our planet. Instead, they may have been scattered across the cosmos, riding on asteroids like Ryugu and delivered to young planets through cataclysmic impacts. This theory, known as the delivery hypothesis, suggests that Earth's earliest ingredients for life may have come from space. Picture the chaotic early solar system. Massive collisions, fiery impacts, and a bombardment of asteroids and comets raining down on a young, barren Earth. It was through this cosmic chaos that life's essential components might have arrived, hitching a ride on rocks like Ryugu. But Ryugu doesn't just tell us about our past. It hints at our future. As we unravel its mysteries, we're reminded of how deeply connected we are to the universe. The same molecules that may have sparked life on Earth could potentially do the same on other worlds. If life's ingredients are truly universal, then the story of Earth could be just one chapter in a much larger cosmic narrative. And yet, there's a lingering question. If Ryugu helped deliver the building blocks of life to Earth, could it also point to where life might go next? As humanity ventures further into space, the lessons we learn from asteroids like Ryugu will shape not just our understanding of the past, but our vision for the future. Ryugu might be a small, unassuming rock, but it holds a big piece of the cosmic puzzle. It reminds us that we are part of an interconnected web of planets, asteroids, and stars, a universe that continues to shape us, just as we strive to understand it. And perhaps, in Ryugu's dusty grains, we'll find not only the story of how life began, but also a clue to where it might one day take us. The Ryugu mission has opened a door to a future brimming with possibilities. As we analyze its samples and uncover its secrets, one thing is clear. This is just the beginning of humanity's quest to understand the universe. If Earth's bacteria can survive in space, what else might we discover out there? What other mysteries await us in the cold, dark corners of the cosmos? Looking ahead, future missions are already in motion to explore other celestial bodies. NASA's OSIRIS-REx has returned with samples from Bennu, another carbon-rich asteroid that could deepen our understanding of the building blocks of life. Meanwhile, missions like Europa Clipper and Dragonfly are targeting the icy moons of Jupiter and Saturn, places where subsurface oceans might harbor conditions ripe for life. Each of these missions builds on what we've learned from Ryugu, pushing us closer to answering questions that have eluded humanity for centuries. The Ryugu samples themselves are far from fully explored. Over the coming years, advanced laboratory techniques will continue to extract more data from these precious grains of rock and dust. Scientists hope to unravel more about the organic molecules found within, their isotopic signatures, and their potential connections to Earth's prebiotic chemistry. Could they uncover definitive proof that Earth-origin bacteria have already ventured into space? Or might they find new evidence that life's ingredients are universal, scattered across the stars? The implications extend beyond science. Missions like Hayabusa 2 and OSIRIS-REx challenge us to reconsider our place in the universe. If the fingerprints of Earth, or even the seeds of life, can be found on asteroids, it suggests a profound interconnectedness between planets, moons, and the vastness of space. The universe, it seems, carries echoes of Earth wherever we look. As we peer deeper into the cosmos, we are reminded of the resilience and curiosity that define us as a species. The universe may be vast, but it seems Earth's fingerprints are everywhere. Whether we're uncovering the origins of life or contemplating its future, each mission brings us closer to understanding the profound connection between life and the cosmos. So, what's next in this incredible journey? The search for life in space is far from over. It's a quest that pushes us to the limits of our knowledge, technology, and imagination. And as we continue to explore, one thing is certain. The more we discover, the more extraordinary the story of life becomes.